All right, let's do some Mathity-Math. It says here, for the resultant of each of the vector sums, find the magnitude and the direction. Okay, so long story short, we're going to add these together and find the magnitude and the direction. Then it says, assume an angle that is anti-clockwise from the direction of I. And I'll explain that in a second when I draw you a diagram. Okay, let's put this all together. Step one, we should add these up, okay? So if we add these up, remember we're just going to add the i's with the i's and the j's with the j's. So 3i minus 2i, that leaves us with just I. Groovy. Okay, and 5j plus negative aj, well that would give us a negative 3j. All right, that is step one. That's actually not our answer or really part of our answer. It's going to help us find our answer, okay? So that was step one. Let's go down here. We're going to need some paper for this. Alrighty, so what I'm going to do here is I'm going to make an xy coordinate plane, and I'm going to use this xy coordinate plane to figure out where this vector is going. And it's going to look something like this. It says go over 1 on I, which is the x, okay? And then go down 3j, which is the y. So 1, 2, 3. And that puts me right here. All right, good. So there you have your diagram of your vector. And why we do this diagram is because it lets us put together what we're working with here. And you can see what it does is it builds a right triangle. And by using that right triangle, we can plug in values and find other things that will really help us get our solution. So we're using this right triangle, understanding that this side is 1 and this is negative 3. I'm going to draw a diagram of just a triangle, okay? So when I draw this triangle, it's going to look like this. And we know that this side is 1, and this side, it says negative 3, but remember for like a side length of a triangle, we would just put in 3, because even though on the coordinate plane this goes down 3, it is still 3 units long. 1, 2, 3, right? It's still 3 units long. This is just telling you the direction it goes. And we know this is a right angle. All right. So when we try to find the magnitude, that's talking about this line right here, right? Because that references this right here. And essentially what you're thinking about, this is just the hypotenuse of your triangle. So again, we're doing right triangles. We either go for the Pythagorean Theorem or a right triangle trigonometry. And because I have both sides, I'm just going to go to the good old-fashioned Pythagorean Theorem. We say a squared plus b squared is c squared. Okay, so my a value is 1, so 1 squared. My b value can be 3 plus 3 squared is c squared. 1 squared is 1 and 3 squared is 9. C squared. 1 plus 1 is 10. 10 is c squared. And then we square both sides and we're going to find out that c is the square root of 10. Okay, and we've actually solved half the question, right? Because we know that this hypotenuse is the square root of 10, and that's the magnitude. So I'm going to go ahead and write that here and just kind of get that done. So we say, okay, magnitude is the square root of 10. Okay, great. Now, the second part of the answer says find the direction. And this is assume an angle that is anti-clockwise from the direction of I. So if you remember that I is the x and y is the j. So we're saying we're at I, okay, and we're swinging down. Whee! And they want to know, well, what is that angle? What would that angle be? What would that angle be right there? So what we're trying to find is we're trying to find this angle right here. We can call that theta. See if I can squeeze one in there. Choop. Okay, theta. That doesn't look like a theta. Okay, so we have that theta. That's the angle we're trying to find. So now we go to right triangle trigonometry. And just in case you need a quick refresher, right triangle trigonometry, we use sine, cosine, and tangent. So it says we have sine of an angle theta. In this case, we're talking about that one right there. Okay, can be found by using opposite over hypotenuse. All right, and I'll clarify the opposite adjacent hypotenuse in a second. And then cosine theta is adjacent. over hypotenuse. And your tangent of an angle theta is opposite over adjacent. Okay, so this is what we're working with. And so we're going to use one of these to try and find this angle here. And okay, so if this is our reference angle, the side opposite that reference angle, that is our opposite side. So this is my opposite side. And the side opposite from the right angle, or the longest side, well, that's our hypotenuse. Okay, and the only one left right here, this is adjacent. And so we're going to choose one of these because we're using this reference angle, and then we'll be in business. Now, a good tactic is to only use the information that the question has given you. That way, if you did make a mistake finding this, it wouldn't mess up your next answer. So we're not going to use hypotenuse because that's something we found. And we may have made a mistake, and so we don't want to use that. So we're going to use anything that has the opposite and adjacent. That's going to give us those two pieces of information. So not this one, not this one. It's right here. We're going to use tangent, okay, because it's using opposite and adjacent, and we have those. They were given to us, okay? So what we do here is we just write tangent theta. That's what we don't know. It's what we're trying to find. Is the same as opposite, which is 3, and my adjacent, which is 1. And in your calculator, what you're going to have to use is the inverse tangent, which would look like this. I'll write it down for you. It's tangent -1. It's this button right here. So you hit second, tangent -1, and then it's going to put in parentheses, and you'd put in 3 over 1, or technically just 3, because 3 divided by 1 is 3, but I'll just be careful. I'll put 3 over 1, okay? Now, make sure your calculator is in degree form, hit enter, and voila, you get 71.565, yada, yada, yada. We're going to go to 3 sig figs, so we know that our theta, our angle value, is 71.6 degrees. There you go. And you can do a quick check here to make sure your answer is making sense. If we started here and we swung down, yeah, we would get almost to 90, but not quite. So that does look about like 71.6 degrees, okay? So our direction, because they told us our starting point was here, our direction is 71.6 degrees. And there you go. You got yourself an answer. Very good job. As always, if you want to be notified when I make more practice problems, please subscribe below, and then you'll get an alert when something awesome comes your way. And if you don't understand, or you have a question, or something I did doesn't make any sense, or you want a different type of problem, or you just love my diagrams, leave a comment below. All right, thank you. Bye.